Today I am going to discuss about faults. What are faults? Civil engineering point of view, faults are the most unfavorable and undesirable geological structures at the site for the construction of structures like reservoirs, dams, bridges, buildings, tunnels, etc. This is because faults are considerably weaken the rocks and render the sites in which they occur as unfavorable places for the construction of above said structures. Further, as long as the faults are active, the site is unstable and susceptible to upward, downward or sideward movement along the fault plane. Therefore, faults are necessarily investigated with special care in dealing with any major construction. Then, what are faults? In the last class, we have studied folds. What are folds? Folds are undulations which are developed in the rock strata due to lateral compressional force. But here, when the rock bed, horizontal rock bed, is subjected to lateral compressive force, that leads to the development of again faults. Or when the rock bed is subjected to tensile force, that also leads to the development of faults. Then what are faults? Faults are fracture deformations and the vertical displacement of the strata, which means beds, produced either by tensional force or compressional force. Whatever the rock bed, when it is subjected to either compressional force or tensional force, that leads to the development of faults. Then what are faults? How it is formed? Very simple. You see, this is the diagram. For example, if it is the first formed bed, M, next formed bed, this one, M bed means the first formed bed. This is N bed. When this rock bed is subjected to tensile force, what happens? When the rock bed is subjected to tensile force, definitely in which we are going to find a fracture, a divisional plane that divides the rock mass into two parts. Along this plane, there must be displacement. One block has to be moved upward, another block has to be moved downward. Then it is called by the name faults. How it is appeared after the displacement? This is M bed, this is N bed, here M bed, N bed. How? This is the first formed bed, here first formed bed, the next formed bed is N, this one. This one is fault plane. When a rock bed is subjected to tensile force, definitely that leads to the development of fault plane along which displacement must be occurred. One portion has been moved downward, another portion has been moved upward. Without a displacement, we do not able to call it is a fault. Faults are fracture deformations and the vertical displacement of the strata, which has to be produced by either tensile force or compressional force. Without vertical displacement, definitely it is considered as joints. Joints again divisional planes in which we do not find any vertical displacement, that's all. If we are going to call by the name faults, there must be vertical displacement. Without vertical displacement, we do not able to call. When a rock bed is subjected to lateral compressive force, what will happen? You see, when it exceeds, one block has to be moved upward on the another block. You see, if it is the fault plane, this is one block, this is another block. When a rock bed is subjected to compressional force, this side block overrides on the another. You see, this is right hand side block. In this case, this one is produced by the tensional force. This one is produced by the compressional force. Very simple. Faults are produced by both the forces. One is lateral compressional force, another one is lateral tensional force. But faults are produced by the only compressional force. There must be fracture deformations. There must be vertical displacement. That rock bed, when subjected to either tensional force or compressional force, then only we can able to find the faults. Then the next heading is parts of faults. Faults contain fault planes, hanging wall, footwall, heave, head, up thrown block, down thrown block, etc. What is this? This one is fault plane. This one is down thrown block. This one is up thrown block. This one is hanging wall. This one is footwall. First formed bed, this one. The second formed bed. Horizontal distance. The horizontal movement is called by the name heave. This one is head. This one is dip. When a block is subjected to tensional force, then that produces this kind of structure. Let us start with fault plane, FF. What is fault plane? The plane along which the rock blocks are displaced by tensional or compressional force is called as fault plane. Without the fault plane, there is no displacement. To take place displacement, there must be fault plane. Next, heave. What is heave? The beds, these two beds are going to show vertical displacement. Yes, but here the beds are not only vertically displaced, but also they are horizontally shifted. The amount of horizontal displacement is called as heave. What is heave? The amount of horizontal displacement of blocks is called by the name heave. Here, head. What is head? The angle between the vertical, this is the vertical, and the fault plane is called as head. The angle between the vertical and the fault plane is called by the name head. What is dip? The angle between the horizontal and the fault plane is called as dip. This head and this dip togetherly becomes 90 degree, which means head plus dip equals to 90 degree. What is footwall? The faulted block which lies under surface of the fault plane is called as footwall. What is hanging wall? Again a faulted block which lies on the surface, which means upper surface of the fault plane is called as hanging wall. One block becomes under surface, another block becomes upper surface. The block which lies under surface is called as footwall. The block which lies upper surface of the fault plane is called as hanging wall. What is upthrown block? A block which has moved upward is called as upthrown block. What is downthrown block? A block which has moved downward is called as a downthrown block. Very simple. Here, downthrown block which has been moved downward. Upthrown block which has been moved upward. Very simple. Without the fault plane, there is no displacement, along which only displacement has to be taken place. If there is no displacement, when we are going to find only fractures, then it is called by the name joints. The next heading is classification of faults. Faults are classified into two groups based on the direction of inclination of the fault plane. They are: number one, normal fault. What is normal fault? Here, this is the diagram to explain the normal fault. A fault in which the hanging wall becomes down thrown block and it is produced by the tensional force is called as normal fault. Another one is reverse fault. Then what is reverse fault? Reverse fault is exactly the opposite of normal fault. In the normal fault, a fault plane is inclined towards the down thrown block. Here, the head, what is head? The angle between the vertical and the fault plane is called by the name head. The head is towards the down thrown block, towards the down thrown side, so that the blocks of the up thrown side and down thrown side are quite distinct from each other. When we come to the reverse fault, just compare it. This one is down thrown block. This one is up thrown block. This one is hanging wall. This one is foot wall. This one is normal fault, this one is reverse fault. Very simple. How do we differentiate these two? This normal fault is caused by tensional force, while the reverse fault is produced by compressional force. But when we come to here again, the hanging wall in a normal fault, the hanging wall becomes down thrown block. In a reverse fault, the hanging wall becomes up thrown block. Here, a fault in which the hanging wall becomes up thrown block, a fault in which the hanging wall becomes up thrown block, and it is produced by the lateral compressional force. A fault in which the fault plane is inclined towards the up thrown block. The head is towards the up thrown side. Here, the head is towards the down thrown side. The fault plane is towards the down thrown side. The major difference is here the hanging wall becomes down thrown block. In a reverse fault, the hanging wall becomes up thrown block. This one is produced by the lateral tensional force, which means normal fault is produced by the lateral tensional force. The reverse fault is produced by the lateral compressional force. In a reverse fault, the hanging wall displaces upward, while in a normal fault, the hanging wall displaces downward. This is the classification of faults based on the direction of inclination of the fault plane. Again, the faults are also classified on the basis of relationship between the direction of the inclination of the fault plane and the dip of the beds. They are: number 1, dip fault. Number 2, strike fault. Number 3, oblique fault. What is dip? What is a strike? I am going to take only this calculator. If we consider this is a rock bed, there is a fracture plane in between this rock bed, which has been produced either by the tensional force or compressional force. You see, along the fault plane, this rock bed is moving. This is the fault plane. This is the one direction. This is the another direction, downward. This is the another direction. The first one is called as dip fault. The second one is strike fault. The third one, which is taken place neither strike direction nor dip direction, between the strike and dip, then it is called by the name oblique fault. What is dip? When the beds are formed, definitely they are going to appear in the form of horizontal nature. When they are subjected to tensional forces, then invariably the beds are tilted due to denudational process. What is dip? Here the bed is in horizontal nature, then there is no dip. When it is inclined, then it is called by the name dip. How do we explain it? When it is horizontal, there is no dip. When it is inclined, there is a dip. How do we explain it? The maximum amount of inclination with respect to horizontal plane is called by the name dip. When the inclination, which means the fault plane, is in the direction of the dip, then it is called as dip fault. The downward movement or rock blocks must be displaced along with the dip plane, along with the fault plane towards the dip. The another one is strike fault. This is the strike. What is the strike? Strike is the intersection of horizontal plane with respect to dipping plane. When the inclination of the fault plane is in the direction of the strike, then it is called as strike fault. Then oblique fault, which means diagonal fault. Oblique fault is one in which the displacement has taken place oblique to both dip and strike direction, which means neither strike direction nor dip direction. Between these two, when displacement has taken place, then it is called by the name oblique fault, which means the inclination of the fault place, it is at an angle to the direction of the dip and partly strike fault. Then it is called by the name oblique fault. What is dip fault? Here displacement has taken place along the direction of the dip. What is a strike fault? Here the displacement has taken place along the direction of the strike. What is oblique fault? When displacement has taken place neither dip direction nor strike direction, then it is called by the name oblique fault. The next heading is groups of faults. Following are the different types of groups of faults. Number 1, Let us start with step fault. We are going to find series of normal faults. Very simple. This is the fault plane 1, fault plane 2, fault plane 3, fault plane 4. Embed. What is a step fault? Here, number of faults can be seen. These two, which means there is a fault plane along which these two blocks have been displaced. When we come to this fault plane, these two blocks have been displaced. As such, these two. When a series of normal faults occur, togetherly, whose the slopes of all the fault planes, you see, all the fault planes are inclined in the same direction, then it is called as step fault. The resulting structure looks more or less like the step of a staircase. What is normal fault? A fault in which hanging wall becomes down thrown block. Here, this block is hanging wall. When we compared with this one is foot wall. When we are going to study with reference to the fault plane 1, definitely this block becomes hanging wall, this block becomes foot wall. The fault in which we are going to find a hanging wall becomes the down thrown block, then it is called by the name normal faults. Here, a series of normal faults can be seen. When we are going to consider F2 fault plane, definitely this becomes the hanging wall, this becomes the foot wall. For every fault plane, the right hand side block becomes the hanging wall, the left hand side block becomes the foot wall. That is the basic concept. Where do we find a series of normal faults whose the slopes of all the fault planes are dipping in the same direction, which appears in the form of step of a staircase, then it is called by the name step fault. The next one is a ridge fault. What is ridge fault? It is also called as horst. This is fault plane 1, fault plane 1, fault plane 2, fault plane 2. Again, embed. This is embed. Here, embed. Here, embed. This one is hanging wall. This one is again hanging wall. This one becomes footwall. What is ridge fault? A fault system consisting of a pair of normal faults again, where both the fault planes inclined away from each other with a common upthrown block is called as ridge fault. Ridge fault is also called as horst. Here you see, when we are going to consider F1 is a fault plane. Here on this fault plane, this is the block which is called by the name hanging wall. What is a hanging wall? A faulted block which lies on the surface of the fault plane. What is footwall? A faulted block which lies under surface of the fault plane. If we consider F1, we are going to find this one is hanging wall. When a faulted block has been moved downward, when it becomes the hanging wall, then it is called by the name normal fault. The same thing can be seen with respect to the fault plane F2. Hanging wall becomes the downthrown block, footwall becomes the upthrown block. Which means a fault system consisting of a pair of normal faults where both the fault planes inclined away from each other with a common upthrown block, then it is called by the name ridge fault. The next one is trough fault. What is a trough fault? This is the fault plane F1, F2. Trough fault is also called by the name graben. We are going to find a pair of normal faults again in the trough fault. When we consider F1, the downthrown block becomes the hanging wall. Upthrown block becomes the footwall. Here also, when we come to the F2 fault plane, the upthrown block becomes the footwall, the downthrown block becomes the hanging wall. What is trough fault? A fault system consisting of a pair of normal faults where both the fault planes are inclined towards each other with a common downthrown block, then it is called by the name trough fault. In a ridge fault, we are going to find a pair of normal faults. In a trough fault, we are going to find a pair of normal faults. But in the step fault, number of normal faults can be seen. Here, one common upthrown block, here one common downthrown block. Here, both the fault planes are dipping towards each other with a common downthrown block. Here, both the fault planes are dipping away from each other with a common upthrown block. Next heading is recognition. Next heading is recognition. Faults are recognized in natural exposures such as hillsides, steep river banks, canal cuttings, mine working areas, and other excavations. If the river valley is straight for a considerable distance, and when it takes a sudden turn, that also indicates faults. The repetition or omission of beds, narrowing or widening of beds indicates faults. The presence of hot springs indicates fault plain. The presence of fault breccia, lichen slides indicates faults. Dislocation of the geological structures such as sills, dikes, or even whatever the intrusive igneous structures also indicates faults. Next one is engineering consideration or importance. If the dam is traversed, if the dam site is traversed by faults or fault plains or fault zones, are most undesirable for dam construction and reservoir construction. If the dam site is traversed by fault plain, definitely the stored water will be get entered into that fault plain, through which that comes to the downstream area, or sometime when the displacement will be continued, definitely the dam will be breached. Fault zones often form potential oil traps. Faults provide passages for the percolation of water. Particularly when we are going to find a massive rock mass, definitely on which even precipitation takes place, even heavy precipitation takes place, that water does not able to get entered into the groundwater aquifer. When that area is traversed by fault plain, through that fault plain, the groundwater gets entered into the groundwater aquifer. Such a way, fault zones are helpful to seeking the groundwater. Fault movement causes landslides and earthquakes. Fault spring is formed where the aquifer intersect the fault plain. Sometimes faults are responsible for lakes, swamps, and marshy places. Fault zones are highly porous and permeable, through which groundwater enters into the tunnel. Fault zones are potential surfaces for future movement of the rocks or even rock blocks. Such site is not suitable for tunnel construction.